So my name is Mehmet. My friends call me Baytaș. That's my last name because I grew up in Istanbul in Turkey, and in Turkey everyone is called Mehmet, so it's not very useful. Uh, so I go by my last name, and my Twitter is Dr. Baytaș. Doctor because I do have a PhD, literally in interaction design. So that's a bit of information for you about me. I do have a website that you should definitely visit. And this is what it looks like. We will be getting back to this site at different points in the talk. But yeah, that's all about me. I currently work at Attio. I build this website that you're looking for. So I'm the designer. I'm one of the 2 design engineers at our company. And I'm responsible for keeping this website alive and cleaning it up and making it beautiful and all of these things. I don't do this alone. There's a team of more than 30 people contributing to this website across content, across design, across making money with the site. Sam, our guy over there, is the money master. He makes sure that the site is profitable. And yeah, I want to acknowledge all of my team and my friends. Are you guys here? Is Dario here? Has he arrived yet? No. Classic. He will probably show up like in 2 minutes. But yeah, there's a whole team working on this site. It's a big one, and we're proud of it. We are, of course, hiring for various roles across product engineering and design. And yeah, you can see the open roles here. Even if you don't see an open role, feel free to subscribe to our careers newsletter. Feel free to just make a general application and reach out. We are always looking for great talent, such as the wonderful people in this room tonight. So this is the site. I will show you a few pieces of the site and tell you about how I think about them, how we built them. There is a lot of interesting things on the site, a lot of these like animations, a lot of motion design that we've done. All of this is done in code. So this is not like a video or Flash or something like that. We literally code these in React and animate everything. We have these kinds of interesting pages meant for developers, which animate in interesting ways. We have dithering shaders. We have live updated GitHub grid with our actual code contributions pulled from our repos on our site. This is like literally the actual Attio product being developed you're looking at here over the last year. We have Easter eggs. I think, is it hacker mode H? There you go. It goes green. So we do a lot of fun things on the site, and yeah, we'll talk a little bit about those. But that's what most of my time goes to these days. So this talk is about musical thinking. I wanted to, I thought about like, what should I talk about to these wonderful people? What do I even know? Like, what am I? Because I'm not a particularly great engineer. I'm not even a very good designer. I was like, why did they hire me to build this site? And I realized they hired me for my taste and opinions and things that are not design and not engineering that I kind of know and bring into play and make us more productive in the process. So today, the thing I want to talk to you about is music. I am, or used to be, an actual musician. This is me playing the guitar, just to show you that I'm qualified to talk about this. It's not particularly relevant to the talk. This is very old. This photo was taken before AI was invented even. So this is like 2000, I don't know, 10 maybe. So it's a real photo of me, and I still do have this guitar at home. We can do a call one day, and I can show you on the video if you want actual proof. I'll play some bass for you at some point. But I used to be a DJ, and I did some production and things like that. So I got exposed to a lot of ideas around music. And that's what I want to talk to you about today, because I think, now that AI has already taken our jobs, like I don't write any code. Does anyone still write code? Can you raise your hand if you actually write code? There you go, like 4 or 5 people in a whole room of design engineers. So like, what are we going to do? What is there left to do? What's left to do is making decisions, architecture, deciding what to do, making sure that things are coherent and there's a system and there's a brand. In other words, what some people might call creative direction, making sure we're like sort of visually, creatively, aesthetically in the right place. And also like constructing the process of how things get built. It might be with like AI and, you know, setting up your AI rules and systems and things, but also between people, setting up these systems. So this is what the job has become. And interestingly, all of these, I think, rely on our vocabulary of mental models and language, which may or may not come from design or engineering. What I mean by this is, for example, so now that we're prompting and like managing the AI as our job, how do we become more effective at it? There's a difference that you will probably have seen between telling the AI to just make the page load faster versus telling it to like go and optimize the fetches so things load faster and then the site loads faster. If you use this approach, like if you know the words and the terminology and the architecture that you're supposed to describe, you will get much better results with prompting these things. Similarly, if you know design patterns like React programming, you know, factories, facades, and you know, a bunch of these things that I don't even know about. Here's another site with like programming, design patterns, engineering patterns. If you know about these, your whole task of like prompting and also reviewing the code gets much faster and much more effective. And also in design, for example, you can go to resources like this and say, find out the names for various aesthetics. You can find out the names for like, I think AI generative people call them srefs, like in Midjourney and places you can supply these as a code, but equally as effective is just using their names and like finding out the names of particular aesthetics from these design resources. There's a lot of things like this on Pinterest, on other websites that you can look at. This is just one of them. Jari or Kari or whatever, however you read this, I don't know. But yeah, knowing these languages, these terminologies help you be more effective at prompting and doing design engineering in the modern age. And I think music is also one of these domains where knowing the language can really help you. I think it's a rich source of concepts, ideas, language, terminology to do our jobs faster, easier, better, and in a more entertaining way, all at the same time. So I will show you some ideas from music and music production and synthesizers and things like that. And the goal here is not that, you know, you will get a particular like grand point out of this talk, but the goal here is that you become interested in at least one of these ideas and just, you know, find out about it and apply it in your work, or connect to your own interest, which may or may not be music. It might be for you like basketball or golf or, you know, cars or whatever, but there might be terminologies, ideas there that will help you for design engineering. So this is not a new idea that you can learn from music and apply in design engineering. Kandinsky has written about this. This is Kandinsky's art, by the way, and this was probably based on some kind of music that he actually painted visually. He says color influences the soul, color is the keyboard, the eyes are the harmonies, the soul is the piano, the artist is the hand touching the key, causing vibrations to the soul, yada yada. So there's a rich literature about the correspondences or the relationships between music and visual arts and design and all of these things. And also scientifically, in human perception, these things are linked. In research, people have been found to consistently match, for example, higher pitched sounds with small objects, brightness, vertical height. These are associated with like higher pitches, and lower things positionally and larger things are associated with bassier, sort of lower sounds. So this is not a new idea, but specifically I want to show you some specific ways that I apply this idea of learning from music and applying in design engineering. Hopefully I will be able to go through 5 ideas. Idea number 1, harmony. This is Johannes Itten's color wheel. The idea here is that if you go about selecting, for example, things with particular spatial geometric relations between, let's say you selected green and the red over here, which lie sort of in opposite ends of the spectrum, then you will achieve like good palettes. If you want 3 colors, you want to space them equally apart on this color wheel, so you get a point from here, a point from here, and a point from here, and that will help you compose good designs. This is similar to the idea in music of the idea of intervals and chords and scales, where if you use particular frequencies, particular notes that have particular mathematical relationships to each other, then it works very well and it makes music. So the idea is that there are, when you use consistent aesthetic relationships, consistent sort of like intervals and mathematical relationships between things, it creates meaning and it creates good design. Here's an example that is actual music. So here we will demonstrate the idea of playing inside the chords, where the melody is related to the harmonic structure in the first part, in like the first 10 or 15 seconds. The second part is going to be outside, and it's going to be very obvious to you when you hear this. Let me play. Yeah. This is inside. Now he's outside. And going back inside. Now. No, now, yeah. Yeah, I think clearly, I think here the moments where he's like connected to the harmony and when he's not. And similarly in design, for example, when we work with colors, if you look at color palettes like this, these are palettes where each color is obviously connected to each other and it creates a particular feeling or particular vibe. And then there are examples where colors are at odds with each other. They are not related or deliberately unrelated, and it creates a more sort of like this jazzy, more chaotic vibe in these colors. Joseph Albers, painter, designer, has done a lot of artworks and even written books about this effect, where the meaning of colors is always determined in relation to the other colors around it. That's sort of the main idea here. And we have obviously like tools like Adobe Color, where we can specify color relations. And if we sort of lock this one in and we go to maybe HSP mode, and if we move this around, you can see that it's easy to pick from like this color wheel, these colors which have particular relationships with them. So this is color. The same applies to also typography. So any time we're dealing with a spectrum, dealing with mathematical values, we can work with, for example, typographical scales, which have consistent spacing relationships between them, and it looks good. And the reason it looks good is the same reason why certain scales, certain note-tone relations, harmonic relations sound good in music. Here's a tool that actually implements this. So can you raise your hand if you've seen a tool like this, where you can select like these sort of intervals for your type scale and so on and so forth? So this is a tool that is well known to us, and this is like you sort of, by implementing a consistent sizing relationship between these things, you achieve aesthetics. But the thing I wanted to show you is that these relationships actually don't need to be consistent in the way that they are fixed. You can have them fixed, of course. You can go with like the minor second, which is 1.067 and so on. But you could also have type scales, which are actually like based on the major scale of like the musical major scale. And the relationships between font sizes are actually exactly the same as the frequency relationships in a major scale. You can also have the minor scale. So each step between, like, you can see that the line is not like perfectly sort of curvy like this one. If you go to like the pentatonic, for example, it's a bit more obvious over here. But this is one way of doing like design based on music, for example, where you can design your type scales or any other scale based on musical relationships rather than just like fixed numerical relationships. And I think it gives some interesting results. So that's idea number one. The takeaway here, the idea is that things that are related to each other look better. And relatedness comes in many flavors. So it could be uniform spacing, it could be spacing inspired by music, it could be the numbers of things. And I want to show you some examples from the Atio website. Here, for example, so many things are related to each other. And in my mind, I think this is a good design. And the reason it is good is because there are so many mathematical relationships between so many parts of this. For example, we have 3 columns. We also have 3 distinct font sizes, this one, and this one. We have 3 elements in each box, the picture, the title, the subtitle. And because of repeating these patterns where like the 3 is sort of like really hammered on visually into your head, it looks powerful in my opinion. It's also the case, for example, that we have a 12-column grid outside of here. Let me see if I can, yeah, there we go. And then we're using the outside columns as the padding. So the padding is responsive. And also inside here, the elements also are divided into 12 columns, and they also use the outermost columns as their padding. So we don't use fixed padding values. We kind of do it like very responsively based on the size and relations and like grid systems of things. I know it's a bit vague, but I do have to move on to the other ideas. So I want to give you the takeaway where like looking for mathematical relationships gives you good music, good harmony, but also good graphical systems. So that's number one. Idea number two, step sequencers. I do have a video about this that I will skip because it's a 4-minute video. I don't have time to play it. But if you want to know what a step sequencer is, it's basically this. And it's basically a system where it just has these sort of steps that it traverses. Every step is a fixed time unit, so every step is like 0.1 second or 140 beats or whatever. And then you can, at each step, paint the grooves you want, and you can sort of create these like sounds, and you can make music with these things. There's some techno for you, some low tom, some other tom drum. Yeah, that's techno. Anyway, how does this relate to design? So I use the step sequencer as a construct in design engineering actually to orchestrate animations. This is an example where I just put together this toy example on my website. You can change the step duration, which you can make it faster. You can change the amplitude of each step. You can prompt it to affect not only the amplitude, but also the color of the box and things like that. And we use these things to create widgets like these. Over here, for example, if you see the pulsing of the rings, this animation on this component here is actually a step sequencer. So pretty much all of these widgets here, like this guy is more obvious, like this plays and then this plays and then this plays. We actually have in the code, in the components themselves, there are step sequencers that is controlling the whole animation. So we don't rely on manually coded timing values on each of these little things. We don't rely on them sending signals to each other to say that one is done and the other step should play. There's in the background in each of these boxes a 4-step, 8-step, whatever sequencer that is controlling all of these things centrally, which gives us perfect timing in a lot of the animations that we want. So that's idea 2, step sequencers. Idea 3, mapping. So this is a big deal in electronic music instrument design. If you've played with synthesizers and things, there's a lot of actual research on this that I did dabble in when I was a researcher at the university. But the idea here is that normally, so for example, you have a knob on your synthesizer or whatever, and it controls something. Let's say the frequency of a filter or the color of the box and something like that. But in digital instruments and digital systems, you don't need to have a one-to-one mapping of the input and the parameter. You could have one knob, one parameter that controls a lot of things. And this is, for example, one thing you can do where you have values such as, let's say, temperature that controls the vibe or the tint of a whole color scale. And this is called temperature. It's not called blueness, or it's not actually connected to one variable. It's just a dial that I created where the name of it, the language of it kind of speaks to me. It makes sense to me. It makes sense to my stakeholders. And we can I can give this tool to my creative director, my designers. They can play with this. They understand the language here. And we're able to create these tools which are do the things that we want them to do, but with simpler controls, with controls that are more human readable and so on. A more extreme example of this is actually this one that I did for a secret project some years ago, so I'm actually technically not even allowed to show you this. But the idea here is that you can actually change your entire web design based on a few simple controls. So here I have a density control that goes between dense and vast. And when I flip this, it changes the vertical sizes of these things, the padding and all of that. I can go between edgy and soft. And notice how if I go here, for example, when I go between edgy and soft, not only the corners and the sizes change, but also the typography. The fonts become slightly less bold if I go from edgy to soft. So many of these parameters are just controlled by this little gadget here. And this is what I mean by mapping. And this is a way that you can think about like when you're making animations, when you're sharing designs with stakeholders, trying to give them tools where they can like input their preferences, and you have sort of built the machine or the system that maps their preferences or their language, their concepts to like actual CSS font sizes and corner radiuses and things like that. The idea that you want to look into is the idea of mapping, which is a big deal in the literature of musical instruments. Filters. I am again going to skip the explanation. Who knows what a filter is from electronics engineering or music? Hands up. Not too many people. Okay, I think I'll try to show you with my example. So here's an explainer. I'm going to skip it. I'm not going to play it. Oops. But you can visit it later and see it on YouTube. I'm going to show you what I've built. So using the idea of like musical filters, like band pass, high pass, low pass, you can actually build interesting visualizations. So here, when I mouse over this visualization, it applies a band pass filter or a band boost filter to the place where I'm hovering. I can also add a LFO, which is kind of this filter that automatically traverses the frequency range and does visual things. So this is, for example, like an interesting tool for like if you want to create like animations for the Granola, talking gadget little thing. So this is a way of like thinking about the way that filters would move and your LFO frequency and amplitudes and these things. You can add noise to the thing. You can also have like, I think I built a second version of this where it goes more like, it has presets. So you can have the waiting mode when your system is waiting for you. You can have the seeking mode when it's looking for some data in somewhere. You can have the crunching mode where it's like another preset playing the thing. And all of these are actually just audio filters. Like I literally put the way that I prompt this into existence. We don't write code anymore. So I just prompt it. And the way that I prompt it is I'm like, hey, give me a filter that has like these controls and apply it to this frequency. So I'm thinking in terms of an audio visualizer when I'm building these things. And these are useful for like, obviously, with LLMs and things like that, we want to communicate all kinds of interesting things about the state of the system to the user. So these things have their applications there. So the takeaway here is, motion example also. You can also apply these to like animation. Here I am applying this is the input signal, and I'm applying, let's say, for example, a low pass filter on my input signal to filter out the high frequency disturbances. Or I could also just apply like a high pass filter and only show the high frequencies, like only the high frequency chatter and not the big movements. So you can apply these to motion and animation design instead of like mass spring damper systems that we already know about. You can compose these systems in the language and the concepts of music and filters and signals and so on and so forth. So that's the other filter example that I wanted to show you. Takeaway, everything is waves. Light is also waves. Sound is waves. And in the frequency domain, in those wave area, there's like an amazing world. Finally, like the topic of actual sound design in the browser, where you can do things like this. This is an actual synthesizer running in the browser. These are not samples. There is a synthesizer that has like a random component and also a deterministic component, which changes pitch based on the distance and the time. The random component doesn't, which is why I like to mix them. There's like the attack, decay, sustain, release envelopes, which will give you different sounds, like, if you change them, or something like this, I don't know. You can add filters and change the number of clicks, things like that. So yeah, this like composing sound in the I don't think I have time, so I will skip that topic over maybe. But sorry? Did you make this today? I think I just made it like yesterday maybe. Okay. So like that's the
reading the URL.
Yeah. This I made today. Yeah. No, but this is based on a component that will be on the Attio site that I can't show you now. So the code, I just told it to like, hey, go look into this code base, steal the components, put it on my website. So that was how we did this. But that is the point. Like the whole point is that if you find these languages, these concepts that help you, because the AI knows signal processing, it knows music terms, it knows what a major scale is and a minor scale is. Like I have, for example, if I run Claude, whatever, like these sounds for like super harmonic, I think that's like a minor 7 whatever chord, and that I made with a prompt, like my Claude, do something and come back, It makes these sounds for me, and I just like compose them based on jazz harmony, but I actually don't even know jazz harmony. I just told it to do it because I know that there is such a thing as good harmonic chords, and there are these ideas in jazz. So I can just tell my LLM to go find them and build the sound and compose the chords based on that. So that's the whole point of it. Like if you know the words, the whole like prompting and building these systems is actually super easy and super fast. Like literally everything I showed you today was built last night or today. Almost. I did steal from some past work, but anyway. Yeah, so takeaway, try to build like these mapping systems which take concepts that you know or concepts that your stakeholders know and map them into like these technical things, sometimes by your prompting and sometimes automatically, because there is already like signal processing and music terminology does actually correspond to things mathematically in the movement domain, in the color domain, in the sort of size domain and things like that. that's now it's like calling me to pay attention to it. But anyway, so an example of those is like you can do it at the macro scale and the micro scale. In the micro scale, you can do things like this, where like I don't know, let's grab a photo and just like copy paste this into the thing from the clipboard history, drop it there. You can build tools like this, which will sort of give you like these parameters that you can use for composing visuals. This is a simple example that I built for something. This is a more advanced example that is more sort of advanced, and it has a lot of presets and things like that. This is a terrible photo to show it with. But you can build these machines to create like visual assets and things like that. But then at the macro scale, like at the large scale, you can also build entire brand identities with this idea of synthesizers and mappings and things like that. And a great resource for that is this book. It's called Code Crafted. It's a new book. I think it came out last year. And it is all about generative brand identity design and using these kinds of systems of mappings and input-output, sort of like music-inspired synthesizer-like structures in actual brand design and graphic design. So this is a resource that I really love. And finally, it doesn't have to be music. Today I'm talking about music because I've been doing it for a while. I know the concepts from music. I use them actually. Literally, this is how I prompt. I'm like, give me a low-pass filter, and I apply it on the visual or something like that. But for you, it could be like cooking or mechanical engineering or like stock market or things like that. So yeah, these are the takeaways, and obviously follow me and come work with us at Attio.
Can you open the QR code thing?
Oh yeah, for sure. The QR code. If I didn't close it up completely.
So people have a chance to read.
I'll just, oh, here. There we go.
Yeah, let's do 2 questions.
2 questions.
You choose.
I choose. You were first. You were very quick.
Did you vibe code the whole website for Attio?
Definitely not the parts that we have built since, like before, like the last 2 months. But in the last month or so, I've rarely written any code, like manually. We did spend a lot of time in the tooling. Like that's one thing I thought about talking about. But it advances so fast that like next month's probably going to be like completely different tool chain. But we did also like spend a lot of time optimizing the rules and a lot of systems, like introducing like regression testing and things like that, so that we can actually vibe code everything. And I believe like in a year or so, maybe like programming languages are not going to be human readable anyway. So I don't really see the point of like reading code or writing code in a traditional sense anymore. Although I believe even more strongly now in things like design patterns, things like programming language theory, and like actually knowing, like deeply knowing your programming language so you can like spot, you know, what's going on. That was a long answer. The answer is like yes. Last year, yes. Now we don't. We basically vibe code everything. We do read the code. We review it.
The bytecode, so maybe, I believe.
Yeah, I think so. Yeah. I mean, we're able to generate so much code, like the volume of the code that we're able to write. And this is one of the reasons why I'm getting into sound and things like that, and motion and things like that. It's such a deep level because we can just build these with prompts now. And like a month ago, I was constrained by my time because I had to actually write the code. And now it's the ideas that matter, really. Question number 2. Yes, you were quick.
I'm just wondering, how general do you think these principles are? Because I was thinking, things like you mentioned the pencil number line, where you have the mapping from bigger numbers are associated with brighter colors, or higher frequency, and so on. So we know that babies have that, so that's pretty universal. But what about things like you were talking about harmony, where you kind of like have things in threes, and then you kind of expect that people would react. But if that's based on Western music, would that only apply to people who are working with Western music? Have you thought about that?
Yeah, so it takes some experimentation. Like sometimes you do actually see that there are like the mathematical relationships that apply to sound, sometimes do apply to color, for example. Sometimes they don't. I think this is a good example, like this little thing that I built where it makes the type scale based on the pentatonic scale, I think is really good. And actually when you look at the, especially if I delete some of these things, like 19 and 21, the 29 can go, this one can go. Like this is basically just like very standard, you can see the pattern, like this is the pattern that we all know and use, like 16, 14, 12, 24, 32, 48, like very standard numbers. They do actually come from those like math. Sometimes the math is the same, sometimes different.
Wait, you just deleted one.
I deleted some rows, yeah.
It still works.
I can reset it. Now they're back. Yeah, and I wish like I could even vibe code and show you how easy to actually like it is to modify these things and build these things once you have the right words to say to the thing. But yeah, maybe that should be a YouTube video.
It can actually happen right after all the talks because we're staying here and you can just show.
Yeah, we can do like vibe coding session.
All right, cool. Thank you.